Hello, we are Group 14. Today we are going to presentate about identifying facial and body movement through CNN and monocular tracking algorithm. My name is Samantha.
My name is Agnes.
And my name is Erin.
Introduction. Shoplifting. These days, many shops experience security problems. One of the most common one is shoplifting. Shoplifting is very common because it is not hard to commit this sort of crime, and people are easy to get away with it because this sort of crime has been going on for centuries. So many people have come up with many ways to steal, even more than before, and there are many chances that people can take so they can use to steal. Next.
Okay, now we are moving to our methodology. For the method we use for this research, we propose a method for its facial recognition and body recognition. For the facial recognition, we use set-of-face method, and for the body recognition, we use depth tracker and inertial sensors. Next. First, for the set-of-face method, it is a method that using CNN structure for face detection module. Next. So for this method, we start from capturing the image, and then we are going to track the face from the low resolution and then gradually going up to a better resolution by a little bit so we could get a facial feature point positioning. From there, we're going to extract the facial feature to match with the existing data. Next. And the second is depth tracker and inertial sensors. It is a method that combines two things, which is a depth tracker and inertial sensors. Through using a depth tracker with an additional sensor, it can provide information complementary to the 2.5 dimension depth video and can overcome limitations when just using the depth tracker. Next. For the approach, we use both discriminative approach and generative approach to making a hybrid trackers, so we could tracking motion in real time. Okay, next.
And from both of these methods, we'll be able to extract some results from the which we will be discussing. First, from the face detection. So there are three sets of data that we will be using. And in the set of data will be process the performance based on feature points and the width information. These sets of data and processing performance are extracted from D et al.'s and Elyun's research paper called Face Detection and Recognition Algorithm in Digital Image based on computer vision sensor, which we reanalyze further by our group. And from those sets of data, we'll be able to conclude a few face detection accuracy and face obstruction. And from the face detection accuracy, it can depend on the angle or viewpoint shifting. If the face shifting happens in a high angle, then the accuracy will be lower. However, when the viewpoint shifting are low, the accuracy will be higher. Also, in the face detection see-the-face method, there are using a 5-feature positioning, which will be using key facial features, which is containing eyes, nose, and mouths. However, when the eyes are obstructed, the key feature point will be not be able to detect it. However, when the nose and mouth are obstructed, the 5 facial key feature point will still able to detect the important facial features. And we are moving on to the body detection. In the body detection, there are 4 metrics that will be used for our calculation for accuracy, precision, recall, and F1 score. And we'll be using 3 sets of data set, which is inertial data set, depth data set, and skeleton data set. For the confusion matrix plot of classification using inertial data set, we'll be able to calculate the predicted result with the accuracy result, which is the result of 97.50% accuracy, which is very high, and it's the same with the confusion matrix plot of classification model using depth data set, which is the predictive calculation with the accuracy result is 92.50%, which is quite high and quite near at the true action result. However, When we are using the skeleton dataset, the conversion matrix plot of classification model has a lower result of accuracy because the result of the prediction calculation with the true action is 60%. However, when three of those datasets are combined, became a fusion data, when we calculated the prediction with the true action, the result became 100% true with the true action. The system that is used in this fusion data are containing by matching each action based on the dataset inertial skeleton and depth. When the inertial skeleton and depth resulted in an action based on their dataset, the majority of the result of action will be taken as the true action result, while if none of the dataset produce the same result of action, then the initial dataset will be taken as the true action result.
In conclusion, body movement is more accurate than face recognition. Body movement can detect action in real time, while face detection can have a low accuracy when the face is obstructed or shifted. By using these detection methods, the AI will be able to detect any sudden movement in a person that can be considered suspicious, whether they have sudden sharp movements or expressions that are suspicious. Thank you for listening.